Hey everyone, so we're gonna spend some time now talking about inference in logistic regression. So all the stuff that we did like last week, we really didn't talk about like the p-values or any sort of confidence intervals or anything like that. And so that's really going to be the purpose of kind of this set of note pack or this note packet is just to kind of get into some of that and the types of testing we can do. So for this set of notes, we're going to be using this data set from the National Hockey League or the NHL. And so this data set has observations on like a bunch of different shots that the players took. And what we're interested in doing is modeling the whether or not the shot went into the goal or not. And so the way our response is coded, so this is our response for this problem, it's going to be a 1 if the shot did go into the goal and a 0 if the shot didn't go in or missed the goal or whatever, was blocked or whatever. And so we're going to consider two different predictors. We're going to consider distance, and so that is in feet, and that's just the distance that the shot was taken from. So we might expect that on average, or we might expect that shots that are closer to the goal would tend to go in more often than shots that are farther away. And we're going to look at shot type, which is categorical with these 7 different levels. I just moved here last year, so I'm like trying to get into hockey. It's kind of hard. I still don't really know what's going on, but I guess these are 7 different shot types that the players can take. All right. And so first we're just going to focus on distance. And so we've got our model output here from R. We've also got a plot with distance on the x-axis and the fitted model probability of the shot going into the goal on the y-axis. We can see that in hockey, generally, the probability is pretty low, no matter what distance you're at, but that for farther distances, the probability does seem to get lower. If you're interested, you could YouTube search the farthest shots made into the goal in the NHL, and they're kind of cool. But that would be like these points up here, shots that were really far away, but still went in. Okay, so that's kind of the background. Now let's go ahead and review a little bit from the last note packet. So nothing will be new in this part, so I'll move pretty quickly. And so we've got our response indicator. That's coded as a 1 if the shot was a goal, a 0 if the shot was not a goal. We could jump back to our page of fitted regression output and write the model in logit form. So remember, logit was just log odds. And we're writing it in this form really because it's linear on the log odds scale. And so it looks more like our usual multiple regression model. All right, so we could find some odds calculations. So we could calculate the estimated odds of a shot going into the goal from a distance of 40 feet. And so this is the dot cam, so I can't really show my R that easily, but you could just throw this into R, and you would get an estimated odds of 1.4296. We could do the same thing for 41 feet. And if you did that, you would get an estimated odds of a shot going into the goal of 1.3911. Okay, And so again, this is all stuff from yesterday, so I'm going pretty quickly through it, but let's interpret this coefficient. I think for the first example, we have the slope is actually negative. So let's see what happens when we exponentiate. And so we get this 0.973. So that means that as we increase by 1 foot, the estimated odds are this times lower than what they were before. And so that was kind of sloppy. So let's write that out. So something like a 1 foot increase in distance to the goal is associated with a 0.973 fold change in the odds of the shot being a goal. In other words, if we increase by 1 foot, we're estimating the odds would go down by this 0.973 multiplicative change. So since we're multiplying by a number less than 1, the odds would decrease. And so let's check to make sure that that matches with our odds calculations before. So if I take the odds of when our distance was 41 and divide by the estimated odds when our distance is 40, we've already done those calculations just for this purpose, and if you do this division, you should wind up with 0.973. So we see as we increase by 1 foot, this estimated change in multiplicative change in the odds matches with what we would get from the slope. So we should feel a little bit better about that. Okay, so again, that was all really review from stuff we've done in the past. In the next video, we'll look at some inference, and we'll go through the hypothesis test as well as a confidence interval for the odds multiplier.